Okay, we are live again. Welcome to another episode of Bitcoin class with Satoshi. I'm here with Dr. Craig Wright. He's the inventor of Bitcoin. And my name is Xiaohui Liu. I'm a founder and creator of Script. So what are we going to learn today, Dr. Wright?
Okay, so what we're going to do is continue talking about some of the different aspects of what makes Bitcoin Bitcoin and how to use it, and try and get people to understand a little bit more about nodes, constructing different applications, and really trying to embrace the concept of SPV and not nodes per se.
Okay.
Not this whole that everyone needs to run a node thing.
Yeah, this has been, I don't know, if not the most popular misconception, or at least one of the most.
But the answer is very simple. The process of running a node is defined in section 5 of my paper. Now, the only consensus mechanism in Bitcoin is the creation of a block. So this is very simple. You don't create a block, you aren't running a node. So, I mean, this is the irony here. There are so many people seem to have this idea that they're running a node, but how? You're not actually part of the consensus mechanism. You're not forwarding packets. You're not doing anything. So, what we need to do is get away from that idea that running a node matters. Now, what you can do and what we need to start talking about is the nature of SPV type systems, which is also defined in my paper, of course, but everyone ignores.
Yeah.
Now, the way Bitcoin originally worked and how it should is IP to IP and transfer of transactions between individuals. Not this, let's all send it to the network and have it broadcast around type attitude, but rather, if I want to communicate with you, I send a transaction directly to you.
Yes. Yeah, that's why I call it peer-to-peer, I guess.
Well, the peer-to-peer in true computer science terms would only be the nodes.
Okay.
And not anyone other than nodes. So you're in a person-to-person, a direct communication. So it's not really peer at all because you're not going through anything else. You're not peering with anyone. You're directly transmitting information between individuals. It's effectively a unicast operation.
Yeah, unicast.
That gets settled in peer. Now, which is effectively what you want anyway, because what you're trying to do is send a transaction from one party to another. Now, if I'm sending to you, you're the only person that matters, really, and then you are the one who wants to make sure that this gets settled on the network. So, SPV. I've mentioned all of this before, and I've said individuals can send transactions to each other and store their own transactions.
Yes.
Now, I want you to start thinking a bit bigger than that, though. There's no limit on what you can and can't decide to store, which transactions you do or don't, and which ones you make available to broadcast to others. Now, the nature of how nodes work isn't going to be miners have everything available for everyone at all times, really fast, with high bandwidth, etc. That's not going to happen. A lot of people seem to think so, but the reality is people will start paying for services as they should. So, in internet terms, there's companies such as Alchemy. So you know what Alchemy does?
Like a CDN?
Yeah. Now, that's what's going to happen in the future with Bitcoin. And it's also a methodology for creating data stores and even repositories, not only for yourself, but larger organizations.
This is what you call like an overlay network, I
This
guess.
is part of it, yes.
Okay.
There are infinite number, I mean, unbounded number of opportunities for doing different ways of storing information. It could be sharded databases, it could be the creation of something like a scalable distributed database structure. It could be transaction logs, the same as SQL uses. Um, just distributed across the world, endless. Now, what you can do in this is you can create mapped series of transactions, the same way I've been demonstrating that you can create addressing, you can create all sorts of other functions there that will allow some individuals to have some transactions or even be part of an update process.
Mm-hmm.
So when we're looking at this, what I want you to think about is if, I mean, we extend it from the two of us into what now if I'm running a company database.
Okay.
So I might have a database of all my records and I can have different levels of encryption, external storage, hashing, all available in the equivalent of a sharded system where no one really knows what matches unless they're part of um, sort of the hierarchy of all of the parts of this that get put together.
Okay.
So now, when I've talked about SPV before, I've talked about sending and storing the hash header and the transactions that you care about.
Mm-hmm.
So if you're a CDN, what do you care about?
Like content that my customers ask me to store, their
Yes,
way is accessed
yes.
fast.
So if you're doing that, do you want to store a complete copy of every transaction?
Probably not. Just the ones people access a lot. Oh, yeah.
So if I randomly select, for the nature of this exercise, a pile of transactions out of the blockchain and decide to store those and serve them,
Mm-hmm.
um, does that make any difference to the security of the overall network?
And probably no.
No. I've covered this one before. The information is secured by sort of matched hashes.
Mm-hmm.
And if those hashes are not secure, nothing's secure in Bitcoin.
Yes, I think either
Mm.
it works,
hmm
everything works, or if it breaks, everything breaks. There's no
hmm
somewhere in between. Yes.
Exactly. So my comment here is, uh, why is it not such an easy task to see that you can have sets of sort of nodes that run on different ports, have different access requirements, maybe like HTML, HTTP, have different client sort of matching capabilities, etc.
Mm-hmm. You can, I think.
Exactly. So even then, if even if I'm on the same port, HTTP, people have started doing things like HTML in transactions.
Mm-hmm.
And that would allow you to actually um, embed even SQL and other database commands in script.
Okay.
But I could have in my one machine different grouped SPV transaction groups. I can
Okay.
map
What
those on an external database and say what they all mean.
different groups? You mean like a different access, like a privilege, or what can be anything? Or
No, just how you reconstruct information. So, have you worked with database sharding or horizontal scale databases, Hadoop, Cassandra, anything like this before?
Not in production, but I know the basics, like a sharding, not like a Ethereum sharding, but traditional horizontal sharding.
So what we have is we have a hash, and that acts as an index to point to other
Oh,
components.
yes.
So why can't we do that with something like Bitcoin?
Yeah, you
Why
can,
can't
like
we?
hashes
Exactly.
everywhere. Yeah.
So we could then reconstruct all that information.
Okay, here again, I think I always try to play the devil's advocate. So
Hmm.
isn't that already being done by in some other system, like I guess Hadoop or even IPFS or some kind of like a distributed hash table? Is this so how
IPFS
does it?
is
Okay.
IPFS is a terrible piece of crap that is just a distributed hash table that basically links to information that gets lost. Um, Nothing
So
stops us in the future from having information that is stored on archives in CDNs, etc., provably in Bitcoin. That's the difference.
okay.
IPFS is an anarchist shit show. There's no other way of putting it.
Okay. Yeah.
It doesn't work for a reason. It's a bunch of we don't want no stinking law and order type people
Mhm.
who distrust companies and distrust everything, and hence nothing works. This is the problem of half these NFTs right now, where they point to securely point to a link to a machine that if it ever goes down, you lose your NFT.
Mhm.
But if we had something like that, and it is now uh, pointed to the blockchain as the secured encrypted component, and now you have the capability to have um, sort of the key to access that. That is the component that is real.
Okay. So my understanding now is because of the persistent nature, it's very hard to lose whatever content you have, even in the future. Everything because
Um,
it's kind of like anchored, settled onto the main blockchain. Is it the
it will
main
be,
advantage?
yes. Hmm.
Okay.
Yeah. And of course, we can encrypt it, double encrypt it, etc. If we do this correctly, even things like GDPR and other issues won't be an issue. There are always, even in privacy legislation, ways around all of this, not just knowing someone else having an encryption key and not being able to lose it, but by having multiple layers, algorithms on top of it. So you set the things up right in the first place. But what we were talking about is extending SPV.
Mm-hmm.
So now, if we're doing that, why would you, if you were Apple, how much Microsoft data would you store?
Virtually zero. I don't know exactly.
Unless they're paying you money, yes.
Mm-hmm.
Um, Similarly to any other group. So once again, we can end up with um, corporations building business models on top of Bitcoin.
Okay. So how does this connect out to SPV?
Um, it's the same model. It's a limited node.
Okay.
You're sending and keeping transactions based on what you need and matching them to the hash header.
Mm-hmm.
So
So the way I see it
there's
for
no
now.
going out to the blockchain and being part of a peer-to-peer um, network to get information. That can happen in the background. You want data. You connect somewhere, you get data.
Okay.
This
So
is
how is this
the
different from like let's say the current we have a clouds, right? Cloud, all this kind AWS or Google Clouds, all this. Is it more like a black box? You kind of have to
no.
trust
I
what it
mean,
is.
why should it be different?
Okay.
It's just a better, more secure way of doing all this. That's it. Don't think we're throwing away everything. Why not? I mean, you could build Hadoop on this, build SQL on it. As an example, one of the key aspects of SQL is transaction logging that allows you to rebuild the entire server.
Yeah, we talked about last class. Yes.
Yes. So not everyone wants that information. Miners will get paid to create a hash chain and store it. Others won't. Now, there are other aspects here too. When we're talking about chained transactions, and we've got multiple transactions one after the other, the miner at the end of the day, long term, only needs to archive small amounts of data.
You mean most of it will be pruned?
From a miner's point of view, yes. You'll end up with archive nodes, content distribution nodes, people paying for bandwidth.
Okay.
So if I have 100 chained transactions and only the last of those is valid and spendable and a UTXO at the end of a block, how many transactions as a miner do I need to fully care about long term?
Just the last one. I think that's the only one in the UTXO.
Yes.
Okay. I think here I'm a little bit confused because if SPV, I understand if you're like we talk about I'm just a regular user. I receive some payment. It's easier for me to check without downloading everything. But what about databases or even clouds? What kind of a usage the SPV plays here, the role?
The same.
Okay.
How is it? Why should it be different?
Because there is payment, but here is the same transaction, just different types of transaction. It can be like a
stop thinking of it as payment. Get rid of that word out of your memory altogether for the moment. That's how you pay miners for access to services. Right at the moment, we're talking about data.
Okay, data as in data in the transaction, part of the transaction.
Anything. Okay. Don't think so small. Anything. Switches. Anything. Anything. Any data that you can imagine that has been created on Earth, will be created on Earth, can be created on Earth, can be part of this universe, can be part of this anything.
I guess
data. Full stop.
Okay.
That's it. Data. So tell me, how does SPV work?
Yeah, basically you have a chain of block headers, very lightweight, and then you only have a small node like a Raspberry Pi. Even that you can connect, get all the chain. You can get the headers.
Get rid of Raspberry Pi. I mean, yes, you want to keep the headers, but no. You haven't read my SPV paper, have you?
Okay, that's my understanding. Okay, yeah.
No, nothing that's on the internet about how these things work outside of what I've told you is right, as usual. No.
Okay.
I take the last transaction and its Merkle path.
But then you have to say the root of the Merkle path has to point to a valid block header.
Yes.
Doesn't that require you to keep you have the chain of block headers?
Well, I always said you had to keep the chain of block headers.
Oh yeah, okay.
I mean, that's always there. The 80 bytes for every block header should always be there. But that's not what we're talking about. We're talking about transactions.
Oh, okay.
So how do I validate a transaction?
Oh, you have the transaction, you come in, you have the Merkle proof. You also send the Merkle proof, so the receiver, you can use this too. It can make sure it's it connects to some header. So it knows this is valid.
Do I need to ever connect to a node to do anything with that?
I mean, assuming you already have the headers, no.
Exactly. So the only thing I need from nodes is the headers. So now the nodes are doing their bit and sending the headers, and you and I are transmitting data. So what what do we require?
We just mentioned the transactions and all the Merkle proof.
Mm-hmm. So if I'm going to be a content distribution site, what do I need to store?
You only have to store the transactions that your users are interested in and the Merkle proofs. And you also assume everybody has a headers so we don't forget it. Everybody has.
Yeah. Now, do I need to validate every Merkle proof?
You mean the CDN?
Yeah.
Or the.
Anyway, the CDN or the user.
I think it depends on whether the user asks you to do it. You can, but also you can skip it. So the user won't get access.
All right. So
you can also
I'm going to get you to think about this again. If I've got say a transaction log that's 1,000 transactions long.
Okay.
And I've got transaction 0 and I've got transaction 1,001.
Okay.
So it's just a bit longer. And transaction 0, I have the Merkle proof showing that it's valid. Is that valid?
It starts from 0, right?
Yeah, well, whatever the number. The first one I've got, number 0, I have a Merkle proof showing where it is in the blockchain.
Okay. Yeah, you only show the transaction 0 is valid.
So now I've shown transaction 0, I've also got a string of transaction sort of IDs showing where 1 went to 2, went to 3, went to 4,
so,
to 101.
I think I'm getting
and I have the proof for 101. Do I need to prove 1 to 999 or 1000?
No, I think you only have to validate the last one, because otherwise, if any of the previous chain breaks, the last one won't be valid. So.
Exactly. So, I mean, do you see now that if we're sending data, we can have big streams worth of large chunks of data with a small proof and a small proof. And if they match the headers like in the blockchain, they're valid.
Yes. I think, that's I think the wonders of hashes, chain hashes.
So what does this mean if we're going to form large streams or calculations or anything else?
You don't have to validate every chain, every transaction in the chain. You only have to validate the tip of the chain. If that's valid, everything before it is valid. So that can probably help you to reduce your load of validating.
So now, if we have also done something like we talked about, having data from one transaction proven into the next.
Okay.
One of the things you've been we've gone over before. Output as input to another transaction so that we can have pseudo state.
Oh, okay. Yeah. The push transaction. Okay.
Now, if I have that information in some sort of transaction type that must always take information, and the miners are validating that,
okay,
can I trust the stream of information?
Yeah, because it's we trust the miners to do the job. So.
Yes. And if you want, you can go and validate it all you want because you've got your Raspberry Pi node. And
yeah, you can, but not,
you don't have to.
Not needed.
Yeah.
Okay.
And you'll go out there and go, yep, it's right. And that's fairly much it. So, given that, tell me what sort of things you might be able to start building.
I don't know, CDNs. That's first come to my mind.
Well,
You
yes, but
can
bigger than that. So what is a hash used for in um, distributed databases? What's one use for it?
index.
hmm So if we're pointing to other uh, bits of information, do I need to have that in the same transactions?
No, no.
No. So can I, for instance, create a index of other transactions in a separate transaction stream?
Index to others. I think it's doable, but
Hmm.
I'm not sure like what will be the usage of that. Because for
Well,
normal transactions, every when you spend, you refer to the previous transaction, right? There's a transaction
mhm.
ID there. You are saying you may refer to some other transactions, somehow put in I don't know, outputs or
Multiple ways. I could even do it in sort of address headers, in input and output information. Uh, I could have a series of like metadata type tags in transactions that would work. XML fields, like markup language type fields that would point to other things,
mm-hmm,
which would allow me to basically say, uh, this transaction is now referencing A, B, C, and D, and these are the orders of these other transactions that you must get. This is where they are.
mm-hmm,
Now, as a further example, um, imagine that I create a transaction that points to location information.
okay,
If I have a block header and I have a Merkle path,
mm-hmm.
how quick is it to find information?
I think very quick. I think it's you have to first identify which block, and then you follow the path. You
hmm
know where it is.
Yep.
Yeah.
So if I have a way of indexing and quickly finding information, what do I have?
I don't know, like a Google lookup table or
You've got lookup
uh,
tables, you've got ways of indexing information,
mm,
and if you can index information on one set of transactions, then of course you can build a whole series of alternative data structures.
okay.
What do you think you might be able to do with that?
Yeah, I was just saying it's like what Google is doing. It's just indexing
Hmm.
all the worst information.
That's one way of doing it, yes. But and a further example, white paper 0001, one of the first, well, actually, the first
First,
one that we went in for publication and
mm-hmm,
patenting. Probably not the first one I wrote, but the first one we went for patent. That was a general ledger.
okay.
So, what do you have in general ledgers?
You just have the different entries.
Correct. And they all need to link and be sort of findable in order,
Mm-hmm,
which you could sit there going, yes, Bitcoin is a series of linked invoices or linked documents, but that's probably not going to get you too far if you're a complex organization running many departments, etc.
mm-hmm.
So, how is your knowledge of accounting?
Practically zero. I think
So,
double entry, triple entry. Yeah, I've
mhm.
never.
All right, so let's do a little bit of example there. In a general ledger, we're going to have access to other journals and ledgers, etc.
Okay, like a
So
kind
the
of
way
like
that
a.
accounting books work is we
Mhm,
have one book points to other books,
okay. Is
and
this a so-called double entry we're talking about here, or?
Mhm.
the-
Yep.
Okay.
Excuse me. Yeah. So What we are going to do is we're going to set structures of different journals that all link to each other.
Okay.
This is the same way that database tables work.
Oh, okay. Like a foreign key or I don't
hmm So when we set up a foreign key, what we're really doing is mapping something to another entry.
know.
And the same when we do the translation from a transaction log in SQL to the actual database information and tables.
Okay. Mm.
When people enter information into a database, they basically do it record by record.
Yes.
I mean, it's a uh, just because people don't work otherwise. I mean, there's
Mm-hmm.
no stream of consciousness goes into a database to
Mm-hmm.
suddenly have everything there.
No.
So what we now need to think about is what does that actually mean for constructing other information sources?
So you just talk about general ledger is still in the domain of ledger, or we talk about
From an accounting
everything?
point of view, but even bigger. I mean,
Uh,
ledgers can be used for all sorts of things. A ledger system is just a simple database.
mm-hmm.
So,
I can think of it's one way to you can like always cross check because there's only I don't know one set of tables or books. You can
mhm.
at least you can cross validate and make sure it's
And you can make sure that nothing's
integral.
been changed out of order, that people,
Mm-hmm.
and if you do it right with recording the first entry, um, then Bitcoin allows you to now have a system that provably will only have one set of books or databases or records or anything.
Mm-hmm.
That's the beauty, where people sort of multiple copies of information. With Bitcoin, we can have one owned copy.
Mm-hmm. Yeah, I think you talk about this example for
hmm
often like a Bernie
Mm.
Madoff. Maybe he has multiple set of books, so that's
hmm
why he can, cheat I don't know
Mm.
investors or law enforcement. But if you have one
hmm
book, that's probably I wouldn't make it impossible, but probably
Mm.
harder to
Mm.
cook the books.
So
Yeah.
um, I don't know if you've noticed, but there are people who've written sort of mini SQL queries on static web pages.
Mm-hmm.
If you can do a mini SQL query on a static web page, and you can do a static web page in a Bitcoin transaction.
Yeah, you can put the same SQL statement in a Bitcoin transaction.
Hmm. So that would allow you to even do SQL calls, etc.
Okay. Mm-hmm.
So define what um, an SQL table is.
SQL table. I think you have different columns with different fields, and then you have all the data, which each entry is a row. I'm not
hmm
talking about relational databases. So,
Yeah, that's just an example. But yep.
mm-hmm.
So how is that? I mean, is that something we could create in Bitcoin transactions?
Yeah, it's just data, right? It's any data you can put it there.
It's
You
just
can put
data.
the table.
hmm
You can put the table is the data database.
hmm
Just put it inside there. Okay.
hmm So, as a further example of something we could do, um, the last update could be the final UTXO. And if we follow that through, our
Mm-hmm.
system now provably can say what the last update is.
Mm-hmm.
From the last update, we can say whether the database is valid or not.
Okay.
Even if it's not something that is in native form on the Bitcoin database, like
Mm-hmm.
Bitcoin Ledger. if we have the equivalent of a SQL transaction log, tell me what that individual SPV content server can now build.
You can pretty much build just another type of database that's kind of like an anchor to the Bitcoin ledger. Yep. And you can, it's a system, so you can have arbitrary. It's not only one database, because for now, when people talk about, we only talk about UTXO database, but since you can embed any data, so you can have any arbitrary databases over there.
So one problem that old buggers like myself have is content format changes. So if you think about image formats,
like a JPEG and
how many other versions of image format have there been?
I don't know. Like, it's always changing. I think hopefully it's getting better, but I'm not sure.
I mean, there are a few common ones like JPEG and GIF, but there are also quite a number that have disappeared.
Okay. Yeah, because I remember if I want to see some of the pictures I take with I take like years ago, and then somehow I open on the latest phone, or it just cannot open because the format is not recognized anymore.
Yes. So an example, I used to use EFX, which was an alternative to TIFF.
Okay.
But no one uses EFX anymore.
And
it's even hard to get a viewer.
Okay. So how is this related to database? Or?
Imagine I had put information out there on the web.
Okay.
All I need to do is even follow a trail of how to convert that. 15 years ago, if I'd gone through and converted all my EFXs into TIFFs, I'd be fine, but I haven't.
Okay. Yeah, I think you are probably not the only one.
Exactly. So imagine now that I want to get access to those.
Okay. You mean the web pages or the original photos?
The photos.
Okay.
Why can't I just automate that process?
Okay. Automate.
So if they're now on sort of a CDN connected to the blockchain forever, that format will, even when it dies, have something it goes into. It will have a viewer.
Okay. The viewer, where is it hosted then? You mean just like at the web pages? Web pages can be gone, but
yeah, it could be a web page, could be an application, it could be a filter that links to things. But the interesting thing here is when you have all of this information and transactions out on the web, you might even need to go through multiple steps. EFX may not be directly transmittable into TIFF. You might need to go through some other third-party application first. But what you would be able to find is it went to that, that went to that, and there would be a way of getting it. So may not always be the quickest way, but if I wanted to access information from my now 25-year-old digital camera, I had one of the first ones, I would be able to somehow find a way of accessing it.
Okay. It's stored by some CDN, and that's a permanent recording. Okay.
And all you need is, of course, a filter that does an update. That filter allows you to get to the next format, etc.
Mm-hmm.
The same with other data.
Okay.
The same with all your updates to things, if you wanted them.
Mm. So let's say take this image format
Mm-hmm.
example. Let's say you have some old format, and then how does is it for example I don't know, even in the extreme case you can put the source code of the the reader application just on chain and or
Mm-hmm.
even off chain in some CDN. So later, doesn't matter how long it goes, and now you don't have any third party to do this for you. But in the
Mm-hmm.
worst case, if you really want to do it, you can actually get the instruction how to decode it.
You could, yes. Now, I want you to think about something else. If I am constructing a stream of data where I need to validate this end and this end,
Mm-hmm.
and where I have transactions, potentially I could do something as an optional either or type format where I can validate it with a hash of a hash proof or the information that would give me that information in the first place. Um, if then conditionals will allow me to have if block of data or other transaction information to spend.
Okay.
So I can put the block of data out there, but have it spent with the hash that is then signed, meaning that over time miners can even start losing data but keeping streams of changes. Now, the way that would be is if I have file A and then it merges slowly over time to file B,
Mm-hmm.
the same way GitHub records
Mm-hmm.
the
Yeah, that's what I
differences.
feel. It feels like a Git.
If I only have the differences, there
Mm-hmm.
are ways of proving these all over time. So I can um, have a provable string where I can prove most of the information, although it could be kept somewhere if I really wanted to be that silly,
Okay. So you
allowing
can
me to allowing me to have the ends of the transaction
mm-hmm.
and still be able to prove things.
Mm.
On top of that, I could even have a big block of data and then only say these are the bits that change.
Okay. Yeah, it feels like you almost like put the Git diffs just into the blockchain, so you can always, because Git is almost like a
Mm-hmm.
timestamping. You can have different versions, so you can pretty
Yep.
much go to any it's almost like a Git checkout. You can go to any
Mm.
revision you want,
Yes.
and it's always there.
Um, that would be really handy when I'm playing with my Word files that get eaten every now and again when
Mm-hmm.
OneDrive screws up or when Google Drive screws up or something like this.
Mm-hmm. Yeah. Okay. So I haven't been you know corrupted by Google Drive, but anyway, I think some people say that, and now they're asking for people to pay. So.
Yeah, well, I had it. I had to actually try and recover a file, at least in part, from memory the other day, because I don't know what happened. OneDrive
Mm.
messed up, is the only way to put it, and didn't save my file properly and
Mm.
lost wherever the hell it was indexing it. And yes, I had an assignment due that day.
Okay.
Yeah, so luckily I've still got
Mhm.
some old memory carving tools that work well enough.
Okay. Yeah, I think it's
Um,
that's a good excuse. You can always tell why it's late or it's gone because
oh,
the hard drive now it's corrupted.
uh, unfortunately, I didn't get any. Um, wasn't going to get that, but luckily I managed to get the damn thing back. But
Mm-hmm.
anyway, um, so once again, what I want you to start thinking about is how we can put lots of information out there, but not everyone has to have it.
Yeah, it doesn't make sense. Everybody has everybody else's data. It's just
But some people will. If I'm
okay.
running email services, I'm going to want to be able to store information for people, especially if they want me to say that I'm going to provide fast access for them. If I'm providing fast access, it's very simple. I'm going to be charged with sort of penalties if I don't provide access. So if I have a variety of clients, I can start flagging different transaction types. I can start putting different address structures. This is something I always tried to get people to understand. The piffy little address structures that I put out there when I first created Bitcoin are not the be all end all and sort of main goals of Bitcoin.
Yeah, I think
they
it's
were yeah, sorry.
Yeah, I think you made it that clear. You said now we only have a, let's say, pay to public key, but I want to have script so you can support any type of transactions I can think of, like a escrow, I don't know, multi-sig or anything, but people just use payment.
But that can even go a lot further. I've been trying to point out that if we have little flags, it could set something on a particular like wallet that acts as either a viewer or a type of front end or something.
You flag, you mean like you know which type of this address, like
So,
a general address it is?
yeah, if I tried to run a BTC SegWit address on normal BC, even a BCH sort of copy coin wallet, what would happen?
I don't think I can recognize. There's
It
no.
wouldn't. If I tried by default to use a Beach32 address in BSV, what will happen?
No, nothing. It's like an old format. Now it's not recognizable.
So, but the whole thing is different applications can be set up with these. This is one thing people don't seem to get. You don't need to see all transactions. If I have a particular transaction type, I don't want to see everyone else's.
Yeah.
So if I'm running something and I'm using Bitcoin as a US dollar marker and having other assets,
Okay.
why would I have a address that anyone else recognizes?
You don't. It's like maybe you're in the UK, you don't care about I don't know, like a
So if
USD
I had
tokens.
a land registry where I'm recording information about transactions in property deeds, why would I have a standard address format?
You probably don't. You don't have to. I mean,
Do I want to be able to send my property deed via hand cash?
You could, but if you can ask them, but I don't think usually people
Well,
trade
I'd probably
houses
want to have
on
a
hand
custom
cash.
version. I mean, think about it for a moment. What happens if you have a tokenized asset and you accidentally send it to a normal Bitcoin address?
You can be burned if you are not careful.
Then you have to go and beg and get people to fix things, and it costs a lot of money. So um, that's the whole point here. That was part of why there are checksums and other such things in standard Bitcoin addresses, why it won't just work, why there are bits that get stripped out and other such aspects of how Bitcoin functions. The same should apply to other alternative structures that we create.
So you're saying like if you have different like almost like a template type of transactions, you probably need to have different addressing format. Like some start with 3. That's just one simple example with just some unique prefix, but you can have anything just on top of it. Put I don't know, other prefix, other checksum, or any postfix, anything you can. So wherever
anything you can think about.
Okay, so the beauty of this is the different wallets that can handle different type of transactions. So and they will not even access accidentally, spend some other type of.
So if you
coins.
let's now extend that idea a little bit beyond even that. If we are constructing a web page, do all web pages have the same format?
Depends on what you mean. I think it's if you talk about static, just HTML, that's a standard. But
let's say we've got rich data sets and we have XML used and script pages and other such things like this. We have different extensions and browsers recognize them differently.
Yes.
Is a JSP page the same as an ASP page?
No.
Is XML stored in HTML format?
No.
Are they given differentiators to let your browser know that?
Yeah. It's kind of some meta info inside the HTML page. So different browsers, they can know how to, either it's a JavaScript snippet or it's a ASP or I don't know.
So
JSP.
We could also have one wallet type that sees each of the different transactions and processes them differently.
Okay. So basically you're saying that the transaction itself encodes information on how to decode them or use them?
Yeah.
I mean, almost like HTML.
So this is where weeks ago we were talking about templating and having structured formats for transactions. If we do that and have different address structures for all of this, then that will now give us additional information we can use. So even with information, one of the things I've pointed out many times is that the checksums and certain aspects of Bitcoin addresses are not in the script.
No, it's not even on chain. So
no. So if I made an address that used the SHA-512 hash format,
okay,
could I do that?
Can you do that? I think yeah, it's just almost like a UI.
So that's a wallet SPV function. So it goes back to SPV. It goes back between users interacting. So I can send you an address function and other information that will be passed and checked by your machine. And that information can allow you to have other payment information.
Yes, you can. Yeah.
So as an example, I could give a SHA-512 payment format or access format for sending me data, but that SHA has a complex XML form or XBRL form template design that must be met that matches a particular set of Bitcoin templates. And rather than sending all of the different updates, I could have those sent offline. And now, as I send you the 512 bits of information, you match the particular template.
Yeah, it's almost like now I have a regular payment, like a hand cash, but also I can have, I don't know, like a touch app, mobile app. When you send me, when you use a payment to send to my touch, I cannot see. It's like it's invalid, right? Vice versa. If you send some touch to my hand cache, I cannot look at it in my wallet.
Yeah. Same sort of thing. But we can take this much further than you're thinking about even. The whole thing here is to remember that this is data, and what we do with it, what other machines build, it's up to your imagination.
I think, yeah, you meant talk about it. Don't limit the thinking to just payment, because when people usually think about, maybe it's just a term, it's coin. So it's all think about this payment.
Yeah. So on your hard drive, what happens with the how is the information in a dynamic web page stored?
It's in the server. I have to request, and then the process is coming back to me in my browser.
But generally speaking, what you're going to have is a whole lot of static information that a server then does some processing on, and your information does some processing on.
JavaScript,
Yeah. Okay. So on your side, there might be Ajax or something silly, even sillier than that. On the other side, there might be a JSP page on the server that renders information. But all of this points back to static files and databases. And if you have a database structure that updates and securely maps information, you can have a database. And the other allows you to have files that when different browsers run them, different things happen. The same way right now, if I run, a Java class file in Notepad, it doesn't do anything.
No,
if I try and load Python pandas sort of information in Google Chrome, I don't think it will do anything. Well, actually, never know. I actually should try that if you do it right. And I mean, I'm sure that you could do something to mess everything up in Google, but
maybe there's a hack, but in general, like the browsers only understand JavaScript, so not Python.
Yeah. So, expanded what you think you could do now?
Yeah, I think it's almost like you can put the web pages inside transaction. You can also put kind of almost like either.
What I need people to stop
database.
thinking is that every node has to do everything. That stupid bloody Ethereum mentality needs to go. Every node can be unique. Every machine can be unique. Every server built on top of Bitcoin can be unique. Every type of SPV structure you can think of can occur if it's commercially viable to make it.
Yeah, it sounds like we don't determine what kind of a business or service that's out there. It's just whoever they can profit from this. I think this I don't know, maybe because of the privilege of being abused by small blockers, so always people think about in a certain way, almost like a PTSD thing.
Yep.
But now even I talk about 1 megabyte script, people were like, "Oh, that's too big." It's like, but whenever you download some any streaming, you go to the internet, 1 megabyte is just nothing. It's nobody care.
Yeah, and if you look at some of the things like Pinocchio files for verifiable computation, they can be a gigabyte.
Yeah, it's the proof size for now. Some of them they can be very big.
And right now that's a problem. 20 years time it won't be.
Yeah, I think somebody said this.
Well, apart from BTC, they'll be even smaller.
I think somebody, probably said this. I don't know, many years ago. if you talk about streaming HD videos, you may think it's a big thing, but one day may not.
Exactly.
Like now everybody's sitting at home watching Netflix.
I know.
Nobody cares.
Yes. I mean, you'd think that would be enough of a proof of what I've been saying, but 10 years later, we've gone from no, you can't stream videos to everyone's doing it everywhere, and people are still arguing about the growth of systems. But anyway, alrighty.
Yeah, sounds great. I think I'm very looking forward to the verifiable computation. They become much more practical, because for now, if you put some proof in a blockchain, it's still a little bit, but I agree. I think it's a new field. It's constantly evolving, like everybody else. Every technology else is. I think it will be just one day we just put it. We don't even think about it. Maybe it runs I don't know, one megabytes of proof size, and nobody just care. It's like one byte.
We'll get
10
there.
years ago. Yeah.
I mean, 1 megabyte, everyone goes, ooh, that's big, but
yeah, script.
It's not.
It's scary.
It's one big. I mean, for frick's sake, you look at the stuff you download on web pages now.
It's huge. It's like a lot.
Yeah, I mean, I look at some of the sort of client-side stuff that they give me, and it can be megabytes in size sent to my browser.
Yeah. So I really want the miners they keep up the game and just bump the limits. But we'll see.
Exactly. I agree.
Okay.
All right.
Okay. Thank you very much. I will. Okay. So just a public service announcement. We will resume after 2 weeks, because there will be CoinGeek.
Because we got CoinGeek and
CoinGeek is coming.
Getting ready for that. So I'll be doing that one instead.
Okay. See you in about 2 weeks. Okay.
Will do.
Okay.
Alrighty.
Thank you.
Talk
Take
to you
care.
soon.
See you.